What is it, Dad?
For my demonstration, I'm using a copper rod about 2 millimeters in diameter, and it's about 70 centimeters long. Extend it horizontally and measure its deflection without load to be about 64 centimeters above ground. Then take a pocket watch, which weighs about 80 grams, hang it on the rod, and measure the deflection above ground to be about 49 centimeters. Taking these numbers and plugging them into the equations, net deflection of 15 centimeters with a mass of 80 grams and acceleration due to gravity gives us a spring constant of about 5.2 newtons per meter. So let's grab another mass. This time we'll take a cassette tape. Replace the pocket watch with this 40-gram cassette tape and measure the deflection of the rod due to the cassette tape. The number comes in at about 56 centimeters. So this time we've got a net deflection of about 8 centimeters, plugging the same numbers into the equations. 8 centimeters with a 40-gram mass and the acceleration due to gravity gives us a spring constant of 4.9 newtons per meter, which is within about 6% of the original time constant, so not too bad. What happens when we oscillate the pocket watch system? Here, slowed down for dramatic effect, we see complex motion. So we've got not only the spring constant of the rod going on, but also a pendulum effect. So that would be rough to calculate. Instead, we'll try another mass, about 22 grams of Play-Doh. I measured the spring constant of this system to be about 4.85. And then took the video into some software that I'd always wanted to try out that allows you to do data extraction from videos, Tracker. And I plugged the video into that software, and we can see that it is able to track the Y motion of the mass and do some numerical analysis based on that. For example, we can take a look at the Fourier transform of the Y deflection and see that the oscillation frequency is somewhere in the neighborhood of 2 hertz. I'm sure there are many other data extractions you can do with Tracker, but that's what I'm doing for now. Instead, we'll move on to simulation. So here are the values that I used for parameters in the simulation. I took the 4.85 spring constant from this system, plugged in the mass of 22 grams, and played around with the damping constant until I came up with a profile that looked about like what I saw in the real world. And there you go.